Okie doke. In this lecture, we're talking about limits with trigonometry. So, as usual, trigonometry is special, as we've had the same common theme all year. And so, first off, two of the most important things to remember about the trigonometric limits are these two facts. So, I'll refer to them as fact 1 and fact 2. Fact 1 is that the limit as x goes towards 0 of sine of x over x is equal to 1. We sort of discovered this in day 1 because we did a table where we filled in values, so this should not be too terribly shocking. And then one that's related to cosine is that 1 minus cosine of x over x as x heads towards 0 is equal to 0. So we'll call upon these two facts, and 90% of the time I aim for the sine x over x, mostly because the reciprocal of 1 is 1, so it makes it very easy to work with on these. So we'll refer to these facts as we go throughout, and we'll simplify, use some algebra in order to solve our problems. So problem number 1 says find the limits, and if the limit does not exist, explain why. So first problem we have is limit as x goes towards infinity of sine of an object here. So this would be the same as the sine of the limit as x goes towards infinity of this rational function, pi x over 2 minus 3x. Okay, now I don't care how you justify the answer, but there has to be some justification. You can do horizontal asymptote type stuff, or you can divide through by the largest exponent in the denominator. I don't really care how. I'm personally going to do the dominant term analysis. So I'm going to say that this is the same as the sine of the limit as x heads towards infinity of pi x over negative 3x. So I can see now that I've taken the dominant terms, still have a limit, but now there's just an x on the top and an x on the bottom. So now I no longer need the limit, and I can say this is just the limit of negative pi, sine of negative pi over 3. And of course that's pointing down in quadrant 4, and it's the long y short x, so it's going to be a negative radical 3 over 2. So that's our first limit. Now for part B, we're going to do fact number 1. Now, this is a great problem to have right here near the top because I need to bring your attention to the fact that it's sine of x over x. So the thing that's on the top has to be the sign of the argument to the sine, sorry, has to be the same as the object in the denominator. So if I'm going to make that work here, I need to put a 2 here because I need it to be sine of 2 theta over 2 theta. And fortunately, this is okay. This is legal as long as I simultaneously also multiply by 2 in the numerator, because 2 over 2 is 1. So now I can perform the limit of sine 2 theta over 2 theta. Both parts are going towards 0 at the same speed. This becomes 1, and the answer is 1 times 2, which is 2. And that's how we'll generally apply this fact number 1. So problem C says the sine of x, or sine squared of x, as x goes towards 0. This would be a limit as x goes towards 0, and I'll split the sine of x squared into a sine x times a sine x, and then there's one copy of x in the bottom. Now, this object is special trig fact number 1. This limit will go towards 1, leaving me with just sine of x. So I have a limit as x goes towards 0 of sine of x, of which now I could just stick in the number 0, and sine of 0 is, of course, 0. And that's our final answer. D looks like it's screaming for that other fact. Remember, the other fact was the 1 minus cosine x over x. So what I'll do on that one is I'll rewrite this as the limit as x goes towards 0. With that 2, I'll take one of them and go 1 minus cosine 3x, put that over x. And then I'll take the other one and write that as 1 minus cosine 4x over x. Notice that I have common denominators, so all I've done here is split these two pieces up. That's a distributive property. And then I have a 1 plus a 1 is a 2, and then the two cosines being subtracted. Now this almost works, but we need the arguments to be the same. So I need a 3 down here, so I'll throw a 3 on the top. And I need a 4 down here, so I'll throw a 4 on the top. And now I can do special trig limit number 2 in this case. And this part becomes 0. This part becomes 0. I'm seeing a 3 times a 0 plus a 4 times a 0. No need for a limit because I'm now done the limit. Final answer is 0. Scrolling down, let's start to use some trig identities to our advantage. Tangent, recall, by quids is sine of x over cosine of x. So I can rewrite this first limit at e as x goes towards 0 of sine x over cosine of x. Still have this x in the bottom, so I'll place that here so that way it's connecting with the sine x, and I can see that we have a sine x over x, which as x goes towards 0 would become 1. And of course I could just evaluate cosine of x at 0, right? Cosine of 0 is just literally 1. So you have a 1 times a 1 over a 1. No need for a limit. I've now performed the limit. Everything's nice and dandy. Answer is 1. Okay, next one I have a couple of signs. Let's see, I've got a limit as x goes towards 0. I have a sine of 6x, and then I have a sine of 8x in the denominator. Now this might cause some stress, but let's go see what we can do here. Let's put a 6x on the bottom so it matches. Compensate by putting a 6x on the top. And just following the pattern that we've been doing, let me put an 8x on the top and an 8x on the bottom. And I'll tell you that this doesn't matter because this object, as x goes towards 0, is clearly going to be 1. This part is technically the reciprocal of 1, but the reciprocal of 1 is also 1. The x's cancel, and so the leftover is 6 over 8. The final answer is 3/4. So this one brings together having a couple of trig functions and also the quid needed to split up the tangent. So let's do it. Limit as x goes towards 0. Tangent itself is sine 3x over cosine x. I'm splitting it nicely so I can work with it later. I have a sine of 7x on the bottom. So I will insert a 3x on the bottom, putting a 3x on top. Insert a 7x on top, putting a 7x on bottom, allowing me to do trig special fact number 1, gives me a 1. This one's the reciprocal of that fact, so that's also a 1. The x's cancel, so I have a 3/7 left over. And when I literally stick 0 into the cosine, that becomes cosine of 0, which is 1. So I get 1 over 1 times 3/7. And our final answer is 3/7. Okay, how about this one? Limit as h goes toward, or x goes towards 0. There's a couple of signs again. So this is a sine of x and a sine of x. On the bottom I have a 3x squared, so I'll put the x and the x for the x squared. And I guess I don't really need the 3, so I'll just write that off to the end as a 1/3. What's gorgeous about this one is that we just simply get a 1 and a 1. These are again trig limit facts number 1. 1 times 1 times 1/3 just yields 1/3. All right, these are the trig facts. Getting tricky with it. I and j. Now remember earlier I said I generally like to work with the signs. So when I look at a problem like this, I'm going to choose to multiply top and bottom by 1 plus cosine of x. My motivation, right, need some motivation for this, is that on the top I definitely have the sine x 1 plus cosine x. But if you think about what we actually have in the bottom, multiplying by 1 plus, right, this conjugate piece, means that I now have a 1 minus a cosine squared of x. And by my PIDs, by my Pythagorean identities, this would become limit as x goes towards 0 of sine of x over 1 plus cosine of x over sine squared of x. And one of the copies of sine will reduce, leaving me with limit as x goes towards 0 of 1 plus cosine x over sine x. Now if I plug in 0 in the numerator, I get 1 plus cosine of 0 is 1, 1 plus 1 is 2, sine of 0 is 0, so I'm in the vertical asymptote case, and my answer is either plus or minus infinity. To analyze that, I'll make a number line, and I'll put that 0 on it. And if I were to plug in a number that was slightly larger than 0, I know what the sine curve looks like. So it's going to be slightly positive. And I know what the sine curve looks on this end, and so I'll be getting slightly negative. And so the problem is that for this particular limit, it's approaching different objects from different sides, right? The limit as x approaches 0 from the left of sine of x over 1 minus cosine of x. is equal to the negative infinity, but that's not the same as the positive infinity, which is what you would be getting as the limit as x approaches 0 plus of the sine x over 1 minus cosine x. And this is an issue, right? Different limits means this limit over all does not exist. Final one for this page is really easy if you know your Kifids. The cofunction identities would say that this is the same as limit as x goes towards 0 of x over the cosine of a complement is the sine, and that's just the reciprocal of 1. If you didn't know that, then I guess you'd have to break down into some of the couscous formulas, right? Addition and subtraction formulas on the cosine, which would be much more painful. Okay, last page. On the top here, let's again multiply by a conjugate. So we get 1 minus cosine 3x over 1 minus cosine 3x. By doing this, we're getting a limit as x goes towards 0. And in the numerator, we have 1 minus cosine times 1, plus cosine, right? I want the conjugate, which means on the top I'm going to get 1 minus cosine squared, but that's just a sine squared. On the bottom, I already have a cosine squared minus 1, which is just an opposite of a sine squared. And then remember, these parts came together to get the sine squared, which means I still have this leftover 1 plus cosine 3x hanging around in the bottom. Okay, but that's no issue. Got limit as x goes towards 0, negative sign, sine 3x, sine 3x, sine 5x, sine 5x. And then that cute little 1 over 1 plus cosine 3x. So as I do my correction factors, I'll put a 3x there and a 3x there. There's my compensation. I'll put a 5x there and a 5x there. There's some more compensation. And I get some great simplification now. Fact number 1. Fact number 1. Reciprocal of fact number 1. Reciprocal of fact number 1. X squareds and x squareds cancel. And of course, cosine of 0 would be 1. So I'm getting negative sign, 1 over 1 plus 1, 9 over 25. So it looks like our final answer is a negative 9 over 50. Ta-da! Okay, last one of this type. We have a limit as x goes towards 0. Let's put a little marker here to keep track of the two. I'll split the fraction up first, make it limit as x goes towards 0. Tangents on top, so I'll turn that into a sine 3x squared. Already have an x squared on the bottom. And the fact that it was a tangent means I also need to put in that cosine of 3x squared there. Plus, since we split it, there's another limit hanging out over here. Limit as x goes towards 0. This is a sine squared, so that's a sine 5x times a sine 5x. And it's over an x squared, so I do have the ability to put an x and an x. So let's fix ourselves now. What are we missing? On this guy, we're missing a 3 on the bottom. So I'll put a 3 on the top. And here I'm missing a 5 and a 5 on the bottom, 2 5s. So I'll throw a 25 on top. Trig fact number 1. Trig fact number 1. Trig fact number 1. And so from this part, it looks like as x goes towards 0, I have 3 over cosine of 0. Cosine of 0, of course, is still 1. And from this part, we have just a simple little 25. And so the final answer is 28. Okay, moving on, practice some extra substitution before we go for today. This, of course, you probably have no problem recognizing from algebra that this is the same as the limit as x goes towards 5 of sine of x minus 5 over x minus 5 times x plus 5. I wish to change this into a new limit in terms of a dummy variable or an alternate variable. The argument to sine is a u, or is x minus 5. So that's what I'm going to let my u become. I'm going to let u equal x minus 5. big advantages, right? Like, for example, if we have x going towards 5 of u, I can see that the limit as x goes towards 5 would then be of x minus 5. And that's just a plug and chug. 5 minus 5 is 0. Furthermore, if u is equal to x minus 5, that would mean that x would be equal to u plus 5. All of this together allows me to take the expression I had, which was a sine of an x minus 5, but that's now u, over x minus 5, which is u, multiplied by x plus 5, and here I can see that x is u plus 5, so this would become a u plus 5 plus 5, and as x goes towards 5, I can see that u was tending towards 0. And what's gorgeous about that is now it's in the special trig form number 1. There's my copy of 1. If I replace u with 0, I'm getting 0 plus 5 plus 5. That's a 10. So our final answer here is going to be 1 over 10. And the final problem for this packet would be sine of pi x over pi x. Let's let u equal the pi over x, so that then we can take a limit as x approaches infinity of u, which would be the limit as x approaches infinity of what? Well, u is pi over x. This is clearly bottom heavy. This is bottom heavy, and so the limit would be 0. This is the horizontal asymptote. And so I can now rewrite my original limit as limit sine of pi over x is u over pi over x, which is u. And I can see that as x tends to infinity, u tends towards 0. And that's literally the trig limit fact number 1.